Assalamu alaikum students. Today we will study what is a spline and what are different kinds of splines. So first of all we will study what is a spline. A spline is basically a function, or a spline function is a piecewise polynomial function joined together with certain continuity conditions satisfied. So it is simply a curve. A spline is simply a curve, and it was a special function defined piecewise polynomials. So basically it defines piecewise polynomial functions. So spline refers to the piecewise polynomial curve. So the solution was to place the metal weights called knots at the control points and then bend a thin metal or wooden beam called a spline through the weights. So spline first replaced polynomials in interpolation. So what is the history of a spline? It was originally developed for shipbuilding in the days before computer modeling, and the term spline is extracted from the name of a flexible strip of metal. Strip of metal, commonly used by the drafters to assist in drawing curved lines. So in design, splines allow local smoothing through data. Now, what is the relation between the piecewise polynomials and splines? Okay, now what is the relation between a piecewise polynomials and splines? A piecewise polynomial function f of x is obtained by division of x into continuous intervals and representing f of x by a separate polynomial in each interval. The polynomials are joined together at the interval endpoints called knots in such a way that a certain degree of smoothness of the resulting function is guaranteed. Now, I can give you an example, that is, for example, f of x is equal to x is a simple function x plus 2, and if x is less than minus 2 and it is x square between the interval minus 2 and plus 2, and also it is you can say that it is e to the power x if x is greater than 2. So these are different kinds of functions. First is linear function, second one is the quadratic function between this interval, and third one is exponential function in this interval. So if I plot the graph in this, then I could say if I take it an origin, then if this is minus 2 and this is 2, then it is x squared. That means if this function is like this, it's basically a parabola between this, but x plus 2 is simply a straight line. That means it is just a straight line, like if I would say that it is just like this. Okay, and this is if x is greater than 2, then this is e to the power x. So that means it is e to the power x, means it is very highly increasing function. Okay, so the splines here are defined by this straight line. It is that joins two different kinds of functions. So this is spline number 1, S1, and this basically it is a knot. Okay, so it joins the two different functions. So this one is S2. Okay, so these are the splines. Here it is a point, here it is one dot or point, but in design or local smoothing through data, it is basically a curve that joins. For example, in shipbuilding, like you have to construct the ship and there are some gaps on the floor, or to fill the gap, you just have to use the patch to fill up the gaps between the ship, any roof of a ship or any floor of a ship. Similarly, in the train line, if you have these two lines and these are split it into like this, and you have to use some kind of a patch that connects the two lines like this. If this is another end, then you have to use here there another patch here. So these are basically the splines. So this is basically a polynomial curve. Alternate name of spline is a thin strip. I would say it is a thin strip. So these are the basic applications of the splines, and there are three types of splines we have to study. First one is of first order, and the first order spline is called a linear spline. Second order is of the quadratic spline, and the third one is third order, that is called cubic spline. Now, what is a linear spline? A linear spline is simply between 2 points, is a spline simply between 2 points for a set of data points like x1 and y1 and x2 and y2. As it is a linear spline, then in its general function should be a linear equation, that is yi of x is equal to ai of x, ai into x plus bi. So this is the general linear spline. So if I want to construct this in an order, then it would be yi of x, y1 of x is equal to x minus x2 into x1 minus x2 into y1 plus x minus x1 into x2 minus x1 into y2. So for 2 points, if I want to generalize this, I would say that yi of x is equal to x minus xi plus 1 divided by xi minus xi plus 1 into yi plus x minus xi divided by xi plus 1 minus xi into yi plus 1. For I is equal to 1, 2, to so on n minus 1. So this is the, you can say that this linear spline is basically same as the Lagrange interpolation. The concept behind these two is same. Now we move towards the quadratic spline. Quadratic spline is of the general equation for the quadratic spline, I would say, is of the form, it is basically a quadratic equation. So yi of x is equal to aix square plus bix plus ci, for I is equal to 1 to n minus 1. So this is quadratic spline, and we have certain conditions satisfied to apply this quadratic spline.